Okay, so the next topic that we're going to talk about, as Ben said, is the advanced teleop code. So we've already talked about generating teleop code, and we've also talked about modifying teleop code to give it some more advanced controls. But there are more advanced ways to get even more control that we kind of skimmed over, particularly the advanced sub-VI action when you're defining actions in the remote control editor. Further, we're also going to use Boolean flags to lock out control actions over our subroutines running. This prevents the servo from receiving commands from multiple sources simultaneously, and I'll show you what I mean once we get into the code. So let's just go into LabVIEW now. And as we can see there in our programs, we actually have 3 VIs here, and I'll talk about those a little more actually as well. Sub-VIs and subroutines is what those were. So subroutines are predefined actions that are bundled together into a sub-VI, which we've previously talked about. This allows us to drop in one piece of code that will perform an entire series of actions. This results in cleaner code that is easier to understand and cuts down on programming time. So now we'll hop back into LabVIEW. So we see we have a search for object sub-VI, a grab object sub-VI, and a drop object sub-VI. So let's go ahead and open the grab object sub-VI and see what it looks like. As we can see, it's just a pretty simple, basic little program or subroutine that's going to do a predefined set of actions. So here we're going to initialize a servo value, we're going to wait, we're going to change the servo value, and we're again just going to go through the series of grabbing an object. And later on, when we can just drop this whole sequence into code without having to look at all the little bits, and this allows us to reuse our code very easily without having to look at it. And if we look at the drop object, it's very much similar, but instead of grabbing the object, it's going to drop it. And if we open up the search for object sub-VI, it's a little different. We see we're initializing servo values, and we have a loop here that's going to wait until it detects an object. And once it detects an object, we can see there's this little grab object. And this is an example of having a sub-VI. In this case, it happens to be being called within another sub-VI, and that's perfectly okay. If we were to double-click this, it would open up our grab object sub-VI, and we can edit it from there. And as you can see, by putting pieces of code and grouping it, we can drop it in just as little icons into larger bits of code that helps us organize and understand our code better. And similarly here, there's another loop that's going to wait and then drop the object once it detects an object. So now that we've talked about sub-VIs, let's go ahead and get into our teleop code. So we'll open up either the default config or a predefined remote control setting. Doesn't matter. We can see here that we have arcade left, and we have all our motors already set up for us, and we've talked about all that stuff before. What we're going to do is talk about the specific action of advanced sub-VI. And what this allows us to do is on one specific button press, we can tell the code to execute an entire sub-VI or an entire set of actions rather than just one small action. So we can do that just by going add VI, and since our VI is already in our project, we can just go to our robo programs folder, and we'll say button 1, when we press it, we want it to grab an object. Since it's already in the project, it's going to ask if we want to copy it or use the existing. We'll just hit use existing. So when we press that button 1, it's going to run through that whole sub-VI that grabs the object. Now we'll say button 2, we can set this to drop an object. Again, use existing. And for button 3, we can tell this button to call the search for object sub-VI. So you can probably see how this can really come in handy, because you can just press a button and have a whole series of code or subroutine play out for you. So we'll go ahead and generate this code. This will just take a few seconds to generate after we give it a name. Teleop mode, create, and that'll generate there for us. And once it generates, we'll see a familiar structure for the teleop code, as it always does after generating, but we're also going to notice a set of parallel loops set up for all our sub-VIs. So here, this should loop familiar to you. This is how the teleop code regularly looks like after it's generated, but in addition, if we scroll down, you'll notice these parallel loops here. And what these loops are doing, if you take a look, and again, notice parallel, they're acting independently from the main loop. So this flag here, it's checking to see when a button is pressed, and if said button is pressed, it's going to call our grab object sub-VI. And if it's not pressed, it's going to do nothing. And similarly, there's a loop for each of our other sub-VIs that we've set. And if we look up here, how it's set up in our main loop, when button 1 is pressed, it's going to set a Boolean flag of 0, and it calls it task 0. And down here, this flag 0 from button 1 is going to let this loop know that it wants to execute our grab object sub-VI. And similarly, button 2 and button 3 each store into a different flag of value indicating whether or not that button has been pressed. Now, one thing that really needs to be noted here, that even though we weren't given any errors generating our code, and we could run our code now, there is a big problem in our code that we still need to address. And that is all three of these sub-VIs are going to be sending commands to our servo motors that control the arm and gripper. And also, in our main loop here, we're going to be controlling the servos for the arm and grip, or the arm specifically, with our right thumbstick. This is a problem because through two parallel loops, we can end up giving servo commands to the same servo from two separate places. And this can create contradictory commands, which can cause your robot to act sporadically or unfavorably. So how we're going to deal with this is, first of all, we're going to move over all this code here and give us some room to work with. Now I'm just going to hold control and create a little room for myself. So what we want to do is we only want to be able to access our servo commands from the right Y joystick if none of these parallel loops are running. So how are we going to do that? Well, first let's case out our code here. And what this means is we want this code to only conditionally be able to access our servo. So what is that condition? Well, if any of these loops are running. So how do we know if these loops are running? Well, we know they're running if the flag has been called. So what we're going to do is we're going to use a flag read. The exact same one that initiates this loop, we can just copy up here. Create a constant for 0. So if that Boolean flag of 0 happens to be set, then we know that this loop is going to be running. So this will be one of our conditions to lock out our code here. But we also have a condition for both of our other loops. So similarly, we'll create Boolean reads for our other two flag conditions. Now, how do we take three different conditions and put them all into one case selector here? What we're going to do is build all three Boolean results into an array, and we can do that by going NXT programming, array, and build array. And with the selector tool, we can just expand this down so that it can accept three results, and we'll wire each of our Booleans into our build array function. Next, we're going to need a comparison function here. Next we're going to need a Boolean function that's going to compare all three of these results. And it's called the NXT OR array elements. So what this does is it accepts an array, which we've just built here, and if any of those results are a true or a 1 value for the Boolean, then that means it's going to return a true as well. So as we can see here, if any of these are true, right now the code is running. This is not what we want. So we'll just right click and we'll go make this case false. So as it is right now, if any of these three Boolean flags are true, then we know that one of these three loops are running. So if we know that one of these three loops are running, then we want the code to do nothing. It's not allowed to access that servo motor while these loops are. And in the false case, when none of these loops are running or doing anything, we'll allow access to that servo motor to be controlled by the right Y. So again, you can see that even if LabVIEW doesn't give you any errors, you can still end up with some pretty fundamental problems in your code. And here we've used Boolean flags as a way to get around that and customize our code even further than we've done before. So now I'll hand it back to Ben.
Thanks, Greg. So in summary, in this final webinar episode, we talked about advanced autonomous and advanced teleop code. We talked about how to use the NXT buttons and Boolean flags to selectively choose from a multiple behavior capable autonomous code. And we talked about how to use Boolean flags and custom sub-VIs within our teleop code to achieve sophisticated functionality. So at this point, I'd really like to thank you for joining us through this webinar series. It's been our pleasure to create it for you. On behalf of myself, Greg, and our friends at National Instruments, I wish you happy gaming.